So we're going to look at the process of global warming. So global warming overview. So we're going to look at what the process is and how global or greenhouse gases can trap this thermal energy. So first we need to understand where the energy is coming from and where it's going. So we have the sun. I'll draw the sun here. And we have the Earth's surface. So Earth surface. Now the sun gives off all radiation, all wavelengths, and all energies of light. The main ones that we're going to look at are ultraviolet, visible, and IR. So we can see visible light. It's a pretty small span of wavelengths. UV and I are much wider, broader. You might know that. So we have UV comes in, and it doesn't do as well. It can give you things like sunburn. It's higher energy than IR. IR radiation from the sun is why the sun feels warm. Okay, so we'll be specifically looking at that because of how it interacts with greenhouse gases. So on the Earth's surface, we have three different types. We have snow, we have water, and we have land. So each one of these surfaces are going to have different levels of reflection of the radiation. So the radiation is going to come in. So this radiation is going to be UV, visible light, and IR, infrared radiation. Snow primarily sees reflection of this radiation. Water also predominantly sees a reflection with a little bit. And this is going to be really important because as we find reduction of landmass that's covered in snow will reduce the amount of this radiation that is absorbed by the surface. So this radiation can also come in, hit the ground, reflect a little bit, but a lot of it's absorbed. So this is absorbed IR, infrared radiation. Now that radiation can't stay on the Earth's surface forever, and it comes back out. So eventually it will go and radiate from the Earth's surface. And when it does that, if there were no atmosphere, and this is just space out here, there's nothing to trap the IR radiation, and it just leaves. So it goes out into space. So we have no net energy loss of or gain. So what we mean by that is that all the energy that comes in from the sun is not being trapped by the Earth. It basically interacts with the surface, absorbs some, reflects some, and all of it eventually goes into space. So if that were the case, then the surface of the Earth, the surface temp, would be frozen if we had no way to trap this radiated infrared radiation. So it would be 60 degrees Celsius colder than it is right now. So that is bad. Okay. And so what we want to look at is, so that, again, this is not real. I mean, everything's real, but there's no atmosphere in this depiction. So we first need to know why greenhouse gases in general are good, because without them, we'd have a frozen surface. So let's look at what happens when we add greenhouse gases. So greenhouse gases, we're going to have the same type of picture where we have the sun. Here, I'm going to try to get my a little smaller, see if that helps. We still have the Earth's surface. So this is Earth surface. We still have our snow, still have our water and so we still have the coming up, a little bit going in, but mostly reflected off our water and our snow. But then on land, we see primarily absorption and this IR radiation that's coming out that is radiated from the Earth's surface. So this is now going to hit the atmosphere. Now the atmosphere has two types of gases we're going to talk about. Every single one of the gases I'm going to put in this box are greenhouse gases. Now a greenhouse gas is defined as anything that can absorb IR radiation. And so the two types are, the first type we have, I'm going to do in green. These are H2O. These are naturally occurring greenhouse gases. So these are greenhouse gases. So green stands for naturally occurring greenhouse gases. So these are going to be found, they were here for a long time before any humans were doing all the things that humans do and creating lots of other things and putting it up in the atmosphere. And so these can also be, as we know, CO2 can be added by humans. So I'll put this in red. So the other type are human-derived greenhouse gases, and that's going to be CO2, N2O, methane, CH4, and CFCs to look at the main contributors. So red stands for greenhouse gases derived from human activity. Now, there's a fancy word for this, and it's anthropogenic. So anthropogenic greenhouse gases is another way of saying greenhouse gases derived from human activity. So it's a little shorter, that's why we say it. And so these are all emitted. So you'll notice that CO2 is both naturally occurring greenhouse gas as well as anthropogenic, which means we have put a lot more of it than was naturally there. And so these are all derived from activity. CFCs are chlorofluorocarbons. And so what happens here is that when this IR radiation comes back, so there's IR radiation, it's going to interact with these different greenhouse gases, both naturally occurring and not, and they're going to make these greenhouse gases rotate, and then eventually they're going to lose some of the energy and they're going to emit there's an equal chance of emitting the IR radiation in any direction, but some of it ends up going back to the Earth's surface. So this is IR radiation, and then that goes back to the Earth's surface, and this would warm the Earth surface. So in this model, we have a net gain of energy because some of the IR radiation goes back into space, but some of it gets trapped and warms the Earth's surface. So this is actually good for naturally occurring greenhouse gases. This is why we're not frozen. But when we start adding more of these anthropogenic greenhouse gases, we start seeing a increase in the average temperature of the Earth's surface that has a lot of impact. So this is global warming, how we're warming the Earth's surface, and then we're going to talk about later on how the global warming will then lead to climate change. So there's global warming comes first. Climate change is a result of the average temperature of the Earth's surface getting warmer. So next we'll look at the major sources of these different gases, and how they're not all created equal. We'll talk about why.